Okay guys, let's continue on the summation of vector. Okay, in summing the vectors we have several methods that you can use. The first one is known as the triangle law. Alright, the triangle law is quite simple, just as what the name say. You will sum it and in a form of triangle. So if you look at this, they have here two vectors A and B. So to sum A and B, just like what we discussed before, simply connect between the terminal of the first vector with the initial of the second vector, and as you can see here, after that we reconnect the initial of the first vector with the terminal of the second vector. Hence, we'll get a new line with a new magnitude and a new direction. This is the vector of A plus B. Alright, so graphically, this is how it should look like when you sum between the two vectors. Okay, the same goes when we use a parallelogram law. In parallelogram law, we simply actually make it as a parallel for each vector. So you have A and B, so we make it a parallel, A, right, with this one and B with this one, and the diagonal, right, the diagonal between the shape that we create here is the result of the summation between the two vectors. Okay, so this is the diagonal line, the diagonal line, and this is actually the summation between A and B. Right, it doesn't really matter which method that you use, because they should give you the same magnitude and the same direction. Okay, that is on summation. Okay, so that is if we have two vectors. Now if let's say you have more than two, they want you to sum several vectors. Okay, the idea will be the same, where you need to connect the terminal of the first vector with the initial of the next vector. So if let's say here we are going to sum A and B, right? No, sorry, A, B, and E, right? So we have this. So A connect with B and connected with E. And what will be the result? The summation will be the initial of the first vector, which is A, with the terminal of the last vector, which is E. So this is where the new vector should be. And you will have a new magnitude with a new direction, right, for the summations, right? The same goes is you'll need to sum A, B, E, and F until F. So this will be the new vector, all right? And additionally, summation of vector satisfied the commutative law, meaning that if you sum A to B or B to A, you will get the same vector. Okay, A plus B is equal to B plus A. Alright, now let's look at subtraction. Okay, for subtraction, of course, when we want to subtract, we are going to say A minus B. So graphically, that is actually impossible to do. We cannot really subtract the vector. Okay, but what we can do is that we can apply what we have learned before, which is a summation, right? Instead of subtract, we use summation. So let's see, what does it mean? A minus B, we change it into A plus negative B. And these two are the same. So how do we sum A with negative B? Alright, so the picture that you look here down here is not really talking about A minus B. This talk about B minus A, right? Let's look at B minus A first. B minus A is also equal to B plus negative A, right? b plus negative a. So we have b, and then this is a, but we don't want to sum it with a, we want to sum it with negative a. So negative, as we have already known before, it should be the other way around. So negative a will be this way. So we have a plus with negative a, and you'll get the diagonal line which is here. This will be the b minus a, or b plus negative a. Alright, they are using parallelogram law here. Right, if you want to use triangle law, just do like this, b, right, and negative a. So you should get the same vector. Alright, so that is if you how to deal with subtraction. You don't subtract, you sum with a negative value. Okay, and again, subtraction here, right, talking about commutative law, it did not really satisfy the commutative law. A minus b is not equal to b minus a, right? Now let's look at scalar multiplication. Okay, in multiplying vector, there are two kind of multiplication. Actually, in general, we have two kind of multiplication. The first one is known as scalar multiplication, where you multiply a vector with any value, right? So let k be a scalar and vector here represented by a, right? And the scalar multiplication of k times a here, okay, will result in a vector whose length is k times the length a, right? Meaning that when you multiply, what will happen is that this vector, the length of this vector will be multiplied by how long? Depending on this value. If let's say our k here is 2, so meaning that this length here will be multiplied 2 times, right? It will be expanding. For example, this, right? This is a, where you multiply with 2, the direction will remain the same. However, the length, the magnitude, right, be multiplied 2 times. That's what it means by scalar multiplication. The same goes if you are, for example, here negative 1 over 2. You multiply with negative 1 over 2. First, we have negative. We know that the direction will change. And then half. So the length will reduce by half. Okay. So this is b. And we multiply with negative 1 over 2. It changed direction. And the magnitude decreased by half. Right. Okay. So that is a scalar multiplication. And if you can remember, we have used actually scalar multiplication in our previous chapter of metric, where we calculate for eigenvector, right? That is where we use scalar multiplication. Okay, so next, okay, let's look at parallel vector. In what situation that we say that these two vector is parallel? Okay, so please try to change the statement, right? If you refer to your books or your notes, there's actually a different kind of definition. Try to please change it into this statement. Okay, two vectors are parallel if they have the same direction. Okay, and scalar multiplies of one another. Okay, so a vector is just a scalar multiplication happen when the vector being multiplied in terms of length, but also can be the other way around. That is if it's just scalar multiplication. Okay, and it is said to be parallel if they only point to the same direction. If they are point to a different direction like this is not parallel, right? So this is parallel. Okay, this is not parallel. Okay, so basically they are parallel if this is obtained from scalar multiplication. However, it should be in the same direction. That is parallel vector. Other than that, it is not parallel. Okay. So component of vectors. Okay, we are going to talk about this more on our next video. Okay, till then, thank you.